Developing and implementing emergency action plans. Certainly a dry topic, I'll go ahead and admit to that. But honestly, except for the inspection and maintenance that as dam owners should be doing on a regular basis, this is probably the most important topic you have. There will be an instance at some point in your dam's life, or the property you own in which you're the manager or the owner or whatever the case may be, that you're going to need to enact the emergency action plan or use a part of it. So let's see what we can get on with this. We deleted the first line that says how to develop an EAP, and the open line would be hire an engineer, but thought that might have been just a little too vague. So we're going to do the definitions of an EAP, the components, and we're going to briefly get into development of it. I do welcome questions if there's anything that needs clarification here, but like before, if you want to write them down, it'd be fantastic as well. So, an emergency action plan is just a formal document of what you're going to do if there is an emergency or an unusual condition at your dam. The term emergency is a little bit of a misnomer, almost like emergency spillway. The reason why engineers and regulators and so forth stopped using emergency spillway is because people kept thinking every time it flowed, or if it did flow, it's an emergency. Well, no, it's an auxiliary spillway. It's a helping spillway. The term emergency is a little bit misleading. And the same thing applies to emergency action plan. It may not always be an emergency. There are several levels, but it may be leading to an emergency. Okay. There's going to be some folks that are going to say to themselves, well, I've only got a 15-foot high dam. It's not regulated by the state. I don't need one. I would tell you unequivocally I disagree. And that I'm not even trying to tell you to hire an engineer. Nothing else. We'll go through a couple things that I think you ought to have in a document. Who to call if something goes wrong. Where are my stockpiled materials if I need to mitigate a seepage problem. Who do I call to unstick a valve if the gate won't open? Just some things that you're not hunting for in the dead of night if something were to go wrong. So that being said, Run For It is not an adequate emergency action plan. It's probably accurate, but it's not adequate. Right. Basic components of an emergency action plan. You need to have an overview, summary if you will. Definition of roles and responsibilities. It can be fairly short, depending on the size of the project, where you live, who's involved. Be pretty large, pretty in depth if it's, Saluda Dam or another structure of similar size. It needs to have a description of event detection that is specific to your structure. We're going to go through that briefly. And importantly, it needs to provide for each of the event levels the communication notification flowchart. What I mean by that is, who are you going to call if there's a problem? It's not going to be the Ghostbusters, I promise you. Are you going to call every downstream property owner? Do you as a dam owner have time? Probably not. Are you going to call 911 or emergency EMD or EMA in the local municipality? Probably. Are you going to communicate with them ahead of time and get them to agree to the emergency action plan so they will continue with their notification? Hopefully. Then we're going to talk a little bit about expected actions, termination, and then reviewing the EAP. In the emergency action plan, there has to be a map that highlights the impacted areas should the dam fail. Depending on the complexity of the project, your inundation map could be for one scenario. Water to the top of the dam and the dam fails. That's pretty much a worst case type scenario. It could be that you do it at normal pool. If it fails at normal pool, which your inundation limits would probably be smaller. You could do it for the 100-year storm. I mean, there's a lot of scenarios that you may want to do it for, but depending on finances, the size of your project, if you ran it for one scenario, run it for the water at the top of the dam and the dam fails. In this presented example, which was developed by the South Carolina Safe Dams Program, they are willing and able to assist with the development of emergency action plans using a program known as DSS Wise Light. It is a fine program. It generally results in conservative answers. In other words, not all the time, it generally creates a larger dam breach zone than actually exists, which is a good thing. If you're going to do it quick, let's do it conservative. Mapping on a different project, we're not comparing the two, done with a program that would require a little more time and effort and data intensity, be done by HEC-RAS. To the untrained eye, there's not a huge difference. But the important part of this is you are defining channel conditions with a series of cross sections. You're defining the depth of water, what roads are impacted, what streams are impacted, houses, so on and so forth. So as a quick summary, as it specifically pertains to an EAP, it is the key component. Without it, unless you have one hazard, unless your dam drains into the Atlantic Ocean or directly into, it's a 15-foot high dam that goes directly into Lake Lanier in Georgia or Lake Hartwell or something like that. You got one house in between there, you better have a map. I mean, I can't think of many instances where you're not going to need an inundation map. And the important part of it from my perspective is it's equally as important for you, but when you work with your emergency management department, for them to understand who or what within the inundation zone needs to be evacuated or notified in the event that there is an unusual condition at your dam. So, as stated previously, South Carolina Dam Safety, at no cost to the dam owner, can use simplified model. Once again, simplified results may not be the best term, but it is an acceptable way to get an inundation map. Conversely, you can hire a consultant, and we're not going to use DSS Wise for a variety of reasons, but we are going to use either HEC-RAS or a finite element model. Generally not the finite element model. And we generally get slightly more realistic or indicative results. Not saying they're better. I want you to understand what I'm saying by that. We're trying to simulate a what-if situation if the dam were to fail. There's a lot of assumptions that go into it. How big's the breach? How fast does it happen? What's the water level? I'm not sure that anybody can pull an answer out and tell you exactly what the water level is going to be downstream. Sometimes being a little conservative is the right answer. Who do we evacuate? Who do we get out of the way? So, as a quick summary, Randy promised no more math, so I promised I wasn't going to put the Laplace equations or differential equations up, but I will give you a brief difference between the programs. DSS Wise Light is a two-dimensional model. That means it's working in 2 dimensions in space. Fantastic. The resolution is somewhat limited because you can only put a certain number of cross sections and the data is a little bit coarser that goes in. HEC-RAS, which is a free software developed by the U.S. Army Corps of Engineers, it does 1-dimensional and 2-dimensional. It can do the Saint-Venant equations for those of you that are interested in that kind of thing, or it can do diffusion wave, which is a quasi-finite element model. And it gets a better resolution because you can put higher quality data into it. Once again, I'm not indicating that the results are actually that much better or worse. You are getting higher resolution. So in a highly congested area, maybe you want to consider it. And if it's a very complex routing where it's routing around a lot of obstructions and it's a high volume of water, there is a need sometimes to go to a truly finite element model such as Flow3D. For 95+% of the projects, you're going to stay HEC-RAS or lower, and I would even argue for 90% of the projects, you could probably stay with DSS Wise. Maybe So, from the dam owner, EAP responsibilities, the dam owner is responsible for the development. Technical sections such as the inundation map do require dam safety or the engineer, and as we said a couple times, DHEC can assist. The dam owner can, using the template that South Carolina has, come up with their event detection, their evaluation, and the potential failure incidents and the corrective actions. And for small projects, that may be appropriate. However, understanding the different emergency conditions sometimes takes a little more experience if you haven't done one before. Not saying it's necessary, and we're going to run through some examples. So, the EAP, regardless of who prepares it, should contain the above items. It should comply with state dam safety requirements, but in the end, it must be developed in coordination with the state dam safety program as well as the local EMD. And the reason for that is, my hope when you walk out of here, you understand when you make a phone call, your job is to try to save the dam. You can't make phone calls to 100 people, but you got to have an organization chart that describes how you're going to get people evacuated, and it needs to be well described. Okay. Step one is your event detection. We've come through today and we've reiterated and said things over and over again, so we're not going to do it again. All you want to do is be able to describe or encounter or look for items that would be considered unusual at your dam, regardless of what they are. In the EAP, those items are going to be classified by a series of either unusual, low level, unusual but probably not an emergency, and then, it's a Katie bar the door, it's a real emergency. So, the observation should be near the dam or on the dam. You should be looking at your instrumentation data, assuming you have instruments. You should be looking at rainfall. Part of this is not necessarily something actively going on this minute. It's could something be going on 6 hours from now or 12 hours from now. In other words, we have a hurricane coming in. I know I can only pass a 100-year storm. They're expecting 4 inches of rain more than the 100-year. That automatically should put you into your EAP notification at a minimum of step one. You know something is developing. It may not go anywhere, but you are putting people on notice. Earthquakes we've covered. Anyway, wow, I just did that. Severe weather or flash flood. Sorry. Got ahead of myself. So then you have to make an emergency level determination based upon the data you have, either an observation you made or a forecast. And we've gone through the seepage areas, the sinkholes, the visual movements. But level one in every state, every agency, to include South Carolina, has a slightly different description of what you're going to call the first level. In essence, it's not an emergency. It is unusual. It did to me too. It is unusual, and generally speaking, we consider it to be a slowly developing event. An example would be a weather forecast that looks like we're going to have a lot of rain. We're having a historic area of seepage. The seepage is still clear. It's picked up a little bit, but it hasn't doubled or tripled, and it's not dirty. Level two. It's a potential dam failure situation or rapidly developing. It's not going to be the same for every dam. Your auxiliary spillway has kicked in. The water is still rising and you're within a foot or 18 inches top of the dam and it's still coming up in the lake. Or there's a gully forming in your auxiliary spillway. It's not to the point of being a dam failure or an imminent dam failure, but it is working that way fairly quickly. Seepage that is increasing noticeably, seepage that is dirty, would fall underneath your event too. And the one I hope we never see, but unfortunately everybody that's in the dam community will see at some point in their life, is urgent dam failure is truly imminent or it is in progress. Water is about to overtop or is overtopping. The boil is, the erosion going on, auxiliary spillway has progressed back to the control section nearly to enter the lake. Basically what you're looking at is, for the first time, there is a likely uncontrolled release of water. Controlled release is going through a spillway. Uncontrolled is coming out, not through a spillway. Once the event situation has been determined, the notification flow chart contained in the EAP must be enacted. So, generally speaking, for non-emergency, unusual, level 1, whatever the term is, the owner will probably be limited to contacting the state dam safety officials. If they have a trusted engineer, may reach out to someone such as that if they have an engineer on, on retainer or on call, or they have someone they've been working with. Going to describe the situation, request technical assistance, but the technical assistance may not even be on that day. The assistance you may get would be monitor the seepage, monitor the weather, call us if it changes. We'll see you in a day or two. Generally speaking, level 2 in order will be call the sheriff, call the EMD, and there should be, and we may cover this again in a minute, can't remember, there should be a statement pre-written in your EAP is exactly what you're going to say. This is the project manager for Willow Lake Dam, and we have a rapidly developing situation, and we are nearly to the point of activating the level 2, and you may need to evacuate people. That statement should be written. I just stammered just then. I'm not even in a critical situation. When you have a high pressure situation, if you have something you can open that book and look at, if it's pre-written and you know what you're going to say, the sheriff, I guarantee you, will appreciate it. Oh, in addition to calling the sheriff, you're also going to call the engineers, dam safety, and everybody else. But at that point, your number one call is the sheriff, because they're going to start evacuating folks, or the EMA. Under event 2, you think you can still save the structure. That's hopefully your goal. Event 3 is call the sheriff, get to high ground in essence. Once again, you should have a scripted statement that you're going to convey key information, and law enforcement should be taking the evacuation into their hands. Certainly you want to consider to monitor the situation, provide updates, but you're literally talking about a situation that has gotten so critical, the odds of you stopping it or being able to stop it are remote. Very, very remote. In instances where when you have a level 3, it's not uncommon that you lose communications for a variety of reasons. You need to have backups if you can. Cell phones be available. Those cell phones are commonplace, obviously. Radios if possible. And that's just a common notification chart. The dam owner makes the first row of calls, and that will be it. And each successive calls, there'll be a series of calls beneath it. They'll be different for each event detection. The flow charts should be set up so that the specific individuals that need to be notified for each specific item are included. We're going to talk about it briefly towards the end, that this is a living document. It needs to be updated for a variety of reasons. Number 1, downstream conditions may change. Development may occur. You may need to revise the inundation map. Secondly, phone numbers routinely change. Names of people that are going to be on the call list may change. All of that needs to be in the notification flow chart. Once the calls have been made or event detection has been established, there are expected actions that must be implemented for whatever the situation is. For example, we've talked about the boil. If the boil is of a certain size or the flow rate's of a certain size, the EAP should contain directions of make a phone call and then put a reverse filter or put a weight over top of it or build a barrier so you're not losing any more material. Those type of items will be contained in an EAP. Equally as important as all the notification is the termination process. If you're at event level 1, once it's under control, the dam owner should notify South Carolina Dam Safety, their engineer, that the flood has passed, the seepage has been remediated, or whatever the case may be, but you need to bring it back down to event level 0 in essence. Similarly, the folks that are in the various event trees should be included in the phone denotification list, if you will, or the termination list. From a maintenance point of view, it should be updated annually. It should be reviewed annually, and then it should be revised as needed. You should maintain records of your revisions and your distribution. We're going to talk briefly about the periodic testing. There are various types of tests. You can do a full-scale test. You're going to bring equipment to the site. You're going to have fire trucks and police and everybody. Generally, that is done infrequently for smaller projects. It is done for larger projects. But a tabletop exercise in which you do bring the major participants in a room is strongly recommended, especially for the first time you run through it. You would actually ask that the phone call get made, at least pretend. You check the phone number and make sure it's accurate. But you walk through to make sure the notification flow chart's correct. You make sure that the set of instructions and the verbiage is correct. Testing it is critical to making sure that your EAP works the way you intended it to. Briefly, the EAP appendices, they vary by different regions and they do vary by the type of dam. Some of the items that I think are important are a glossary of terms. Let me back up. I think they're all important. But glossary of terms, resources available. If you have a seepage condition, knowing where there's filter sand or filter fabric or gravel is important. The local gravel yard, it may just be a phone number and say this is local gravel yard. If there's a gate that has an issue with sticking or not sticking, or you need a diver, having the phone number of a couple divers in the area or that are able to mobilize is a great thing to put in our resources available. If it's an imminent level 2 or rapidly developing, not imminent, and you think you can still save the structure, having the name of a couple contractors with the size of equipment or a place where you can rent equipment should be included in there for resources. Vicinity map, showing the location. Watershed map, I think that's a preference, to be honest with you, but that's happening upstream. We're more worried about what's happening downstream, but there's some reasons why you may want a watershed map. Evacuation map is critical. I will say this, what we have found specifically at Schnabel is when you develop your evacuation map or your inundation map or whatever you want to call it for the sake of this, and you develop it on paper, if it can be developed in a compatible GIS format, most emergency management folks are working in GIS, and if they can upload it to their system and turn it on when the phone call is made, you have made their life exceptionally easy. Exceptionally easy. Other items to include on the list are residents and buildings and phone numbers and contact for highways and residences at risk. If there's a lot of residences, the best thing to do is just block out an area and say all of these folks within this area get evacuated. James Street to the west gets evacuated instead of trying to name every phone number and every address. It's faster. Plan view of the dam, profile of the spillways, reservoir elevation, volume, and spillway capacity. Those seem unimportant to a lot of folks, but if you have an issue and you're trying to lower the reservoir and you feel like lowering the reservoir is going to reduce the hazard, it is important for the engineer or other folks coming to the site to know how far that reservoir needs to be pulled down before the risk is mitigated. So by having that information at their fingertip is important. When we talked about Langley this morning and that boil showed up, we did two things. We put a reverse filter on it and we lowered the lake. Knowing the volume of that lake to us was critical. We knew that if we could drop that lake 5 feet, we felt really comfortable we were reducing the hazard. We got lucky. We reduced the hazard. Who's asleep? Nobody. Everybody. Break time.